Hello everyone, welcome once again. So in the previous class, we complete the examples of the type integration of px plus q upon ax square plus bx plus c and integration of px plus q upon square root of ax square plus bx plus c. Right now, the next topic and the last topic for this year's syllabus, that is integration by parts. Actually, last topic is in this chapter is integration by partial fraction, but that topic is removed from syllabus for this year. So this should be the last topic for you in this chapter, that integration by parts. Now what is integration by parts? So if we compare this with the derivative, so when we are given the product of the two functions and how to find derivative, so we use the product rule in derivative, right? In the same way, if we are given the product of the two functions in integration, so we have to use integration by parts here, right? That is, say if u and v, this is the statement of the theorem, if u and v are the differentiable functions of x, then integration u into v dx equals to u integration of v dx minus integration derivative of u into integration of v dx, right? That is, if we consider this u as a first function and v as a second, then how we remember this? See here, first function into integration of second minus integration derivative of first into integration of second, right? So in this way we remember this theorem and can solve the examples of depending on this. See, first of all, prove that let integration v dx equals to w. If we consider that the integration of v is equals to w, then according to definition of the integration, the derivative of u into w, this is actually the product rule consider here, right? Here what we say, see here, that integration of v dx equals to w, then according to definition of the integration, derivative of w is v, or v equals to derivative of w with respect to x. This is actually according to definition of the integration. Now consider derivative of u into w according to product rule, that is first function into derivative of second plus second into derivative of first, that is u into derivative of w plus w into derivative of u, and dw by dx is what? V. So this is u into v plus w into du by dx, right? Again, by definition, if we see derivative of uw is this right side, then integration of right side is uw, right? According to by definition of integration, uw is integration of right side, right? Then separate the integration in between these two, that integration of uv plus integration of w du by dx, right? Then again see here, integration of uv plus integration of w du by dx, right? So what we consider next step here, see, so what is the next step here? See that integration of u into w means what? W is integration of v dx equals to integration of uv dx plus, here interchange w and du by dx, so integration of du by dx of w, right? Then this integration of uv dx goes to the left side, that is integration of uv dx equals to u into integration of v dx goes to right side, right? Or on the other hand, we say that this is to the right side and this positive term goes to left side, that is negative, right? So u integration of v dx minus integration of du by dx, and w is what is w? Integration of v dx, that integration of v dx, here put the value of w, right? Then the next step what we get, see here, u integration of v dx minus integration of derivative of u into integration of v dx, right? And this is actually the proof of the theorem, this is the final answer, and here dash denotes derivative, so in place of derivative there is a representation of the dash, nothing else. and this is the proof of this theorem of integration by parts, right? Try to understand and try to write down to practice this theorem, because something some confusions are there, but very easy. This is asked in the examination for 3 marks, and if it is asked with 4 marks, so one of the example along with this is asking in the examination like this. See the example on this, that see example, integration of x into e to the power x dx, right? So here x into integration of e to the power x dx minus integration of x into integration of e dx. How it find this? Is the first term is x and second is e to the power x. So first into integration of second minus integration derivative of x into integration of second, right? So x integration of e to the power x is what? E to the power x minus integration derivative of x is 1 and integration e to the power x is e to the power x, right? Again integration e to the power x is e to the power x plus c is the constant of integration. So this should be the final answer here, right? Here how we select the first and the second function, that is by using the Lie rule, right? See here what is Lie rule. So see, we arrive at an integral of, it is example, e to the power x into x square, which more difficult, but it helps to get e to the power x into x square dx. Thus, it is essential to make a proper choice of the first function and the second function. The first function to be selected will be the one which comes first in the order of Liate. L-I-A-T-E, Liate. What is this? So L stands for logarithmic function. I stands for inverse trigonometric function. A stands for algebraic function. T stands for trigonometric function, and E stands for exponential function. So along with this LIATE, the function which comes first in this order, that should be considered as a first function, right? And which is second, that should be the second function considered here, right? So in this way, by using this Lie rule, we have to choose first and second function for integration by parts. So this is, you have to remember, because this is the very important thing, because in derivative there is no any rule to for the choice of the first and second function, because in the product rule, derivative, in derivative we have used the product rule, and in product rule there is addition of the two function, right? But in integration by parts rule, there is a subtraction of the in between two terms. So addition is commutative, so there is no choice of the first and second function. You will select any function as a first, the answer is not affected. But on the other hand, in integration by parts rule, there is a subtraction between two terms in the result of that, right? So therefore, when we select the first and second function, if we consider any function as a first, then the result is different, right? That means the result is affected. Therefore here this this way, that is Lie rule, is used to choose the first and second function. This is mandatory and very important, right? Now see the example depending on this, that integration of x square into 5 to the power x, right? Now if we see this x square is a which function is this? That is algebraic function, right? And 5 to the power x is what? Exponential function. So see, in this Lie, which come first? Algebraic come first, exponential is next, that is after algebraic. So we consider x square as a first function and use the integration by parts rule, right? Understand? Okay. And all other formulas of integration are used in the same way as we use in the previous chapter, in the previous topics, right? So first of all, we use the integration by parts rule and then we proceed, right? See, first function x square into integration of 5 to the power x minus integration of derivative of first into integration of second, right? So x square, and what is integration of 5 to the power x? That is 5 to the power x upon log 5 minus integration x square is twice x. Again integration of 5 to the power x is 5 to the power x into upon log 5, right? then this is the same constant term and integration is find out. So you see all the terms up to final answer is same for the first term. See here, first term is same, x square 5 to the power x upon log 5, that is same for that, right? Now see about the second term. So twice x 5 to the power x into upon log 5, right? From here 2 upon log 5 is constant, take outside the integration, and remaining is what, x into 5 to the power x. And if we see x into 5 to the power x, here also again the product of the two function, that x and 5 to the power x. So again use the integration by parts rule to evaluate integration of x into 5 to the power x. And if we see these two functions, x is algebraic, 5 to the power x exponential. Again that means x is the first function and this should be the second function. So use parts rule, first function into integration of second minus integration derivative of first into integration of second, right? That x into 5 to the power x, integration of 5 to the power x is 5 to the power x upon log 5, and derivative of x is 1, and integration of 5 to the power x is 5 to the power x upon log 5, right? So again this x into 5 to the power x upon log 5 minus 1 upon log 5 into 5 to the power x dx, right? So again 1 upon log 5 is constant, and 5 to the power x, integration of 5 to the power x is 5 to the power x upon log 5, right? Then simplify the bracket, that is 2 upon log 5 into log 5 whole square, and x into 5 to the power x, minus and minus plus 2 upon log 5 into log 5 means log 5 cube, and 5 to the power x plus c. This should be the final answer. And instead we take common from all these three terms, that 5 to the power x upon log 5 is common. So what is remaining in first term, x square. In the second term it is minus twice x upon log 5 plus in the third term 2 upon log 5 whole square plus c. This should be the final answer here, right? So in this way we have to solve the examples of the integration by parts rule, right? First of all, we here mandatory part is we have to use the Lie rule and integration by parts rule very properly, right? Right. Now see the next example. Yes, that integration of x into tan inverse x, right? So again if we see there is a product between x and tan inverse x, and along with x is algebraic function, and tan inverse x is inverse trigonometric function. So by using the Lie rule, if we see inverse trigonometric function come first before algebraic, LIATE. So IA means I inverse trigonometric function is come first, so we consider this as the first function, right? So first function tan inverse x into integration of second means x dx minus integration derivative of tan inverse x into integration of x dx, right? So what is integration x is x square by 2 minus integration derivative of tan inverse x is 1 upon 1 plus x square, and into integration of x is x square by 2, right? Then x square by 2 tan inverse x minus 1 by 2 is constant, take outside the integration, and integration of x square upon 1 plus x square, right? Now we have to think about this integral. This is same as up to last step, first term is completed. Now think about this integration of x square upon 1 plus x square. So here we have to add and subtract 1, adjustment of 1 we have to do here. So 1 plus x square minus 1 is add and subtract in numerator. Why? Because we have to adjust numerator as that of denominator. डिनोमिनेटर में 1 प्लस एक्स स्क्वायर दिख रहा है, तो इसके अकॉर्डिंग न्यूमरेटर एडजस्ट करना है, मतलब उसके लिए आपको 1 और 1 ऐड करना पड़ेगा और माइनस भी करना पड़ेगा, राइट? और इसके बाद आपको बेस सेपरेट करना है. सो 1 प्लस एक्स स्क्वायर अपॉन 1 प्लस एक्स स्क्वायर मीन्स 1 and minus 1 upon 1 plus x square, right? And in next step integration of 1 dx is x, and minus integration of 1 upon 1 plus x square is tan inverse x. Should be the final answer. See, therefore integration x tan inverse x is what? 1 by 2 x square tan inverse x minus 1 by 2 x minus minus plus 1 by 2 tan inverse x plus c. This should be the final answer, right? So in this way we complete the second example. Now see the third one. What is integration of x upon 1 minus sin x, right? So this is not actually the standard form of the integration, so therefore we have to simplify first of all. How we simplify this? See here, we rationalize this, rationalize denominator, that 1 plus sin x upon 1 minus 1 plus sin x, 1 plus sin x से multiply divide कर रहे हैं, right? So x into 1 plus sin x upon a minus b, a plus b से 1 minus sin square x, 1 minus sin square x is cos square x, right? Then x into 1 upon cos square, separate the base, 1 upon cos square plus sin upon cos square, right? So x into 1 upon cos square is sec square, and here what, 1 upon cos and sin upon cos, 1 upon cos is sec and sin upon cos is tan, so sec x into tan x, right? So after multiplication with the bracket, so x into sec square x plus x into sec x into tan x, this should be the next step. Now here we got the two terms or the two separate integrations, and both are the product of the two functions. Here see, x into sec square, product between x and sec square, and here x into sec x into tan x. Here product of the three functions, but sec into tan we consider one function, one term, right? So see, we use the parts rule in the both the terms. So, and here x is algebraic and it is trigonometric, so therefore x is the first function, integration of second minus integration derivative of first into integration of second, right? Plus here also same, x is the first function, integration of second minus integration derivative of first into integration of second, right? So both the integrals can be simultaneously solved, or if you are confused, so consider I1 and I2 and separately solve and then substitute in this equation, right? So either of the cases are correct. Here see what we get then, x into integration of sec square is tan x minus integration derivative of x is 1 and the integration of sec square is tan x dx, plus similarly for the second term it is x and integration of sec into tan, that is sec x minus integration derivative of x is 1 and integration of sec into tan again sec x, right? So x into tan x minus integration of tan x is what, log of sec x, plus x into sec x minus integration of sec x what, log of sec x plus tan x. After simplifying what we get, see, x into x is take common from its x sec x and x tan x, so what we get, x into sec x plus tan x minus log of sec x and minus log of sec plus tan x. This should be the final answer for this example, that the integration of x upon 1 minus sin x, right? Now see the next one, that is integration of e to the power twice x into sin 3x, right? So let I is given integral. So here this is an exceptional case, so we use repeated integration by parts formula here. If to evaluate integration of e to the power x into sin x bx plus c, or integration of e to the power x cos bx plus c, this type of integration, so we considered any function as a first. These are the exceptional cases, so here already mentioned first of all. Otherwise, according to Layard rule, actually the e to the power x should be considered as a second function, but in the exceptional cases we consider as any of the one or the first function and any is other second, right? So first into integration of second minus integration derivative of first into integration of second, right? So e to the power twice x, integration of sin thrice x is what, minus cos 3x into 1 by 3, and derivative of e to the power twice x is e to the power twice x into 2, and integration of sin 3x is what, minus cos 3x into 1 by 3 again, right? So minus 1 by 3 e to the power twice x into cos 3x plus 5 plus minus minus plus 2 by 3 into integration of e to the power twice x into cos 3x dx, right? So this is the first term as it is, and 2 by 3. Now again here we have to use the integration by parts rule. So e to the power twice x as the first function, integration of second minus integration derivative of first into integration of second, right? Again simplify that, what we get, see here, minus 1 by 3 e to the power twice x cos 3x is the same, and a plus 2 by 3 e to the power twice x sin 3x into 1 by 3 minus integration of e to the power twice x into 2, right, into sin 3x into 1 by 3 dx, right. So minus 1 by 3 e to the power 2x cos 3x plus 2 by 9, 1 by 3 into 2 by 3 means 2 by 9 e to the power 2x sin 3x minus 2 by 3, 2 by 3 into 2 by 3, that is 4 by 9 into integration of 2x into sin 3x, right. So I equals to minus 1 by 3 e to the power 2x cos 3x plus 2 by 9 e to the power 2x sin 3x minus 4 by 9 of, this is again we got I as see equation number 1. This is actually given function again. So minus 4 by 9 goes to left side, plus 4 by 9 equals to minus 1 by 3 e to the power 2x cos 3x plus 2 by 9 e to the power 2x sin 3x plus, right. So I plus 4 by 9 of I, that is 13 by 9 of I equals to e to the power 2x by 9 is take common. So what we get here, a positive term come written as the first, so sin 2 sin 3x and minus 3 cos 3x, okay, plus c. So we have to find answer for I. So this 13 by 9 goes to the right side, so it is what 9 9 cancel and by 13 is remaining, so it is about 2x by 13 into 2 sin 3x minus 3 cos 3x plus c. This should be the final answer of this question, right. Okay, now a lot more examples are there, so uh, try to solve yourself. This should be the activity, prove the following result, right. This is actually the only result you have to understand, and you have to remember that, right. So this should be the final answer, and try to complete the activity and try to solve the examples depending on this type. And next type for integration is actually integration by parts, that should be removed from the syllabus. Therefore the chapter is completed here, and try to complete the examples from the exercise, and some solved examples are there also. So try to understand that. If any you face any problem, then contact me on the personal number, and by completing the examples of the exercise, send me the solutions of the questions in my personal number. I will check and respond to you, right. Okay, now in the next class we start the next chapter of the part 2 syllabus, that is the definite integral, right.